on the Algebra 1 AOC, there's a problem to determine the value of this radical expression. So we have 5 times the cubed root of 128 times the cubed root of 54. To simplify this, or to write the answer as an exact quantity, we want to break down 128 and break down 54 into their prime factors. The way we do that is with a factor tree. So it's good to memorize your powers of 2. I know 128 is 2 to the 7th power. So this is 2 times 2 times 2 times 2 times 2 times 2 times 2. And then 54, we have to break down into its prime factors. It's an even number, so I know that's 2 times something. 2 times 27. And then 27 is 3 times 3 times 3. And then all of the prime numbers, those are the ones I'm interested in. So I can rewrite this as 5 times the cubed root of, and we're going to write all of these 2's. So 1, 2, 3, 4, 5, 6, 7, and then another 8. And then 1, 2, 3 3's. To simplify cubed root, we're going to pull out 3 of a kind. So we could pull out a 2. We could pull out another 3 of a kind. Pull out another 2. And then pull out a 3 of a kind here of 3's. So this will be, when we pull it out, that means we're going to multiply that by 5. So 5, now we have times 2, and then times 3. And then on the inside, we still have that leftover 2 times 2. Just going to leave that as 4. Simplify. So 5 times 2 is 10, 10 times 2 is 20, and 20 times 3 is 60. So our answer is 60 times the cubed root of 4. Determine the value of the expression. Write your answer as an exact quantity using only a single radical. Similar problem, this time the operation is division. So I'm just going to rewrite this as a fraction. 4 root 18 over root 6. So 4 times the square root of 18 over the square root of 6. We can simplify or rewrite 18 as a product of its prime factors. 2 times 9. 9 can be broken down into 3 times 3. So I have 4 times the square root of 2 times 3 times 3. And on the bottom, root 6. So the top here, we can pull out a 2 of a kind. We can pull out 2 3's, bring them on the outside. So the square root of 3 times 3 is 3. So we have 4 times 3. And then on the inside of the square root, we still have a 2. And then over root 6. This is 12 times root 2 over root 6. Good. Now we want to rationalize the denominator. That means get rid of the root in the denominator. So take your 12 times root 2 over root 6, and now we're going to multiply by whatever this bottom is. So root 6 over root 6. The reason why we do that is because when we multiply 6 times 6, we get 36. The square root of 36 is 6. So on the bottom, we get 6. On the top, we get 12 times the square root of 12. And 12 over 6 can be simplified into 2. And root 12, we can break down 12 into its prime factors. 2 times 2 times 3. And then pull out that pair of 2. So we get 2 times 2 times the square root of 3, which is 4 square root of 3. Now for this problem, determine the value of the expression. When we're adding or subtracting, not only does the root have to be the same, but the number inside the root has to be the same. So we can't just subtract any of these numbers. We have to make the number on the inside look the same. And the way we do that is the same sort of method. We do prime factorization. So take 40 and 135, break them down into their prime factors. 40, 2 times 20, circle the prime. 20 is 2 times 10, circle the prime. And 10 is 2 times 5, circle the primes. 135 is 5 times. You do your long division without a calculator, so 5 times 2 is 10. 35 is 7. 5 times 27, circle the prime. 27, I know, is 3 cubed, so 3 times 3 times 3. Circle the 3's. So rewrite this expression as 8 times, we said the cubed root of 40 was the cubed root of 2 times 2 times 2 times 5. Minus, and we said the cubed root of 135 was 3 times 3 times 3 times 5. 3 times 3 times 3 times 5. So remember why we did prime factorization is so that we can pull out 3 of a kind. Pull out 3 of a kind. So this is 8 times 2 times the cubed root of 5. And this is minus, pull out a 3, so 3 times the cubed root of 5. Okay, simplify again. 8 times 2 is 16, cubed root of 5, minus 3, cubed root of 5. And now we have the same root, and we have the same number, so we can subtract 16 minus 3 is 13, cubed root of 5. Very similar, this time we have addition. And we can't just add any of these numbers because the roots have to be the same and the numbers inside the root have to be the same. So let's break down 40 into its prime factors. So 48 and break down 162 into its prime factors. 48, 2 times 24, circle the 2. 24 is 2 times 12, circle the 2. 12 is 2 times 6, circle the 2. 6 is 2 times 3, circle the 2, circle the 3. 162, we can divide by 2, it's an even number. 2 times 81. And I know 81 is a perfect fourth root. So yes, it's 9 times 9, but it's also, those 9s can be broken down into 3 times 3, and then another 3 times 3. So these are my prime factors. Let's go ahead and rewrite these expressions. So 5 times the cubed root of 48 is 2 times 2 times 2 times 2 times 3. 2 times 2 times 2 times 2 times 3. Plus 2 times the cubed root of, this is 2 times 3 times 3 times 3 times 3. Okay. And cubed root means we can pull out 3 of a kind. There's 3 2's. So we can pull out a 2 in the front. And we still have, we can call that root, or the cubed root of 6 on the inside. And then here we can pull out 3 of a kind. So that 3 goes on the outside. And then we still have a 2 times 3 on the inside, which is 6. Good. 5 times 2 is 10. Cube root of 6 plus 2 times 3 is 6. Cube root of 6. And 10 plus 6 is 16. Cube root of 6. Determine the value of this expression. We have the square root of 3 times the square root of 45. We can multiply 3 times 45 and then do the prime factorization, but it's always best to work with the smaller numbers. Let's take 45 break it down into its prime factorization. 45 is 5 times 9, circle the 5. 9 is 3 times 3, circle the 3's. This is the square root of 3 times, and then square root of 45 is 3 times 3 times 5. Square root means we can pull out pairs. So pull out a pair of 3's. So this is root 3, and this pair of 3's, now 1 3 goes on the outside, and on the inside we have root 5. So we just multiply the coefficients, so this is a 1 out front, so 3 times 1 is 3, and then we can multiply what's inside the square roots. 3 times 5 is 15. This would be our answer. We cannot simplify this anymore.